channel BYJU'S Exam Prep, and we are discussing IISC PYQ. And here in this class, we'll discuss Discrete Mathematics Part 2. Already we have discussed some question in last class. Fine, you can go and watch my Part 1 video. Fine. So I'm starting now. We need to solve more question. And fine, so I'm solving now. See clearly? So you can join this Telegram channel for more updates. Description दिया हुआ है. And UPSC ESE 2023 mains exam has been out. Fine. And you can share your result and you can get free mock test with our expert panel, and it is going on outside also, outside of this studio. Fine. So, and interview list also has been released. Okay. So you can share your result. And see, these are the classes starting from today only. Fine. Starting from today 8 p.m. on BYJU app. You can download the BYJU app and yeah, we'll solve some PYQ. Fine. Now see clearly, we have solved this question and the answer is okay. We have solved this question. The answer is A. Fine, in the last class. Fine. And we have also solved this question and the answer is D. Negation they are asking. Answer is D for Delhi. Fine. And we have solved this question also, third question, and the answer is A. Fine. For this one, generally what you do, just see, like you can remove some option. Fine. Like for all does not follow and. I told you there exists does not follow. There exists follow and. Fine. So for all does not follow and. So it will not be the answer. Fine. For all follow and here. So it will not be the answer. Fine. Generally you can remove like this. Already we have seen this question. Fine. Hello Rushi. Okay. So, and we have seen this question also. And the answer is what I think we have seen in the last class. 1, 2 and 3. 1, 2 and 3. 1, 2 and 3 are equivalent. In last class we have seen. Okay. So, and this for this one answer is 4. We have seen already. And for this one also, the answer is D. We have seen this one also. Yeah. We have seen this one also in the last class. This is easy one. Fine. P they have given 8, 9, 10, 11, 12. Q they have given X is a composite number. Composite number means they are factor of any two numbers. It cannot be prime. It cannot be 1. Perfect square, you know, like if any integer you can write in the form of a square, like you can write 9. 9 is a perfect square because you can write in terms of like a square of any other integer value. So it is nothing but, you know, perfect square and prime number, you know, prime number everyone know. So they are giving some statement here and they are asking you like which of the following condition is satisfied. Either you can what, minimize this, fine, simplify this, and then you put the value. Already we have discussed in the last class. Either you can directly put the value. You will get 11 as the answer. Fine. In last class we have already done. Fine. If you have doubt, you can ask me. We have done in the last class. Okay. And this one also we have done, and the answer is what? B answer. Fine. B. We have done in the last class. So, and for this one, the answer is what? It is nothing but transitive and symmetric. Fine. We have done in the last class. They are asking about empty set. Okay. So, and we have done this one also, and we have done this one also. Fine. The answer for this one is nothing but, see, this one, first one, and the fourth one is a lattice. So, first one and fourth one is a lattice because every pair have LUB and GLB, least upper bound and greatest lower bound. So, first and fourth is the right answer for this one, first and fourth. Fine. For every pair, there is a LUB and GLB. See here, for this one, see here for this one, if you take this two vertices, see here, LUB will not exist. Fine. Already I told you if something cross like this, fine, it will not be a lattice. Fine. So we have seen this already. If you have doubt, you can ask me. Okay. Now starting from here, see clearly, they have given P, Q, R are the subsets of universal set U. Then P intersection Q intersection R, union P complement intersection Q intersection R, union Q complement union R complement. They are asking to you. Fine. So what is the answer? They have given some options. So either you can simplify this. आप इसको simplify कर सकते हैं. You can simplify. So it is nothing but PQR. I'm writing here. PQR. Fine. Union means plus. It is nothing but P bar. P bar. And what we have Q and R. P bar QR. And what we have plus we have Q bar plus R bar. Q bar plus R bar. Fine. I'm solving in terms of digital logic. Fine. So I think this is the representation of this one. Now you see clearly here, QR is common here. So if you take QR common from these two, what will happen? P plus P bar. So P plus P bar is nothing but 1. Fine. So it is nothing but QR. I'm writing directly. ये दोनों मिलके क्या हो जाएंगे, क्यू आर हो जाएंगे ना. इफ यू टेक क्यू आर आउटसाइड, सो पी प्लस पी बार विल बिकम 1. फाइन. सो क्यू आर इंटू 1 इज नथिंग बट क्यू आर plus q bar plus r bar. If you more simplify this here, q bar, so q will be cancelled. You can directly see here r plus r bar will be what, 1. Fine. I think you know this formula. Fine. Already I told you. See here. So q bar with q will be cancelled. Whenever you see here, q r plus q bar, just cancel q. Fine. Q bar plus r is this. That is q plus r. Either if you want, you can apply distributive property, but directly you can cancel out this one. Directly you can cancel out this one. Fine. If here q and here q bar, so q bar will be cancelled. Fine. So q r plus q bar, so q will be cancelled. Now r plus, now see clearly here, r bar plus r is nothing but 1, and 1 plus q bar is nothing but 1 plus q bar is nothing but 1. So it is tautology. So I think u, universal set is the answer, u is the answer. Fine. U will be the answer. Are you getting my point? U will be the answer for this one. Okay. Otherwise, what you can do, see here, you can use this method also. Fine. We have PQR, my dear friend. Let's suppose this is P, this is P, this is Q, and this is R. Fine. Let me just put some number here. 1, 2, 3, 4, 5, 6, 7, 8. Fine. So 8 regions are there. Now you see here in question P intersection Q intersection R. What is P intersection Q intersection R? Fine. If you see clearly, 6. Fine. So I'm writing 6 here. It is nothing but 6. Union. What we have P complement? P complement means here, if you see P complement means, see here, P complement means 1, 4, 7, 8. 1, 4, 7, 8. And what? Intersection, see, P complement means 1, 4, 7, 8. 1, 4, 7, 8. This is nothing but P complement. P complement is nothing but 1, 4, 7, 8. Fine. Intersection. What we have, see here, Q intersection R. So what is common between Q and R? If you see clearly, Q and R. Common is nothing but Q and R, 6 and 7. 6 and 7. This is nothing but 6 and 7. Am I right? 6 and 7. Okay. 6 and 7. Union, my dear friend, Q complement. What is Q complement? If you see Q complement is nothing but 1, 2, 5, 8. 1, 2, 5, 8. This is nothing but Q complement. Are you getting my point? 1, 2, 5, 8. And what is R complement? R complement is nothing but 1, 2, 3, 4. 1, 2, 3, 4. It is nothing but union 1, 2, 3, 4. 1, 2, 3, 4. Now if you see clearly, see 6 union 1, 4, 7, 8. Intersection 6, 7. But in दोनों में common क्या होगा? 7 is common. So answer will be 6 union 7 union 1, 2, 5, 8, 1, 2, 3, 4. So what you will get? You will get, see here, you will get 1, 2, 3, 4, 5, 6, 7, 8. You will get all 8. It is nothing but universal set. So you will get U only. So the answer for this question is what? U. U is the answer. Fine. So either you can go with this method, just number the regions, fine, and you are able to solve the problem, or you can use digital logic method. Okay. Now see clearly this question. Which of the following first order logic formula is logically valid? Here alpha x is the first order formula with x as a free variable, and beta is a first order formula with no free variable. So they have given some option. Fine. They have given some options. So for this one, I very clearly told you, you need to take some universe of discourse. Either x value can be 1 and 2. Minimum you can take. Fine. No need to take n value. X value will be 1 to n. Just take minimum value and try to solve it. So for this one, see here. Fine. Actually, I know the answer. See here. So let me tell you how you can solve the question. Any one you can take. C. Let me take C. C is the right answer for this one. If you see clearly, there is nothing but there exists x, alpha x imply beta. See here. See bracket. देखो bracket कहाँ पे? There exists x alpha x. What is the meaning of there exist? What is the meaning of there exists? You know, internally it is what? R. So if I take x is 1, it is nothing but, see, alpha 1 or alpha 2 or alpha 2, this implies what? Beta. This is nothing but left hand side. Are you getting my point? See here, alpha, bracket, देखो bracket कहाँ है? See here, bracket यहाँ तक है. This is the bracket, my dear friend. So there exists का मतलब क्या होता है? What is the meaning of there exists? I told you very clearly. This is nothing but or. Alpha of x, if I take x equal to 1 or 2, so it is nothing but alpha 1 or alpha 2 implies beta. This is nothing but left hand side. What is right hand side? For all x, see, what is right hand side? This implies, for all means, you know, and. So see, for all will be imply on, see, if we remove this comma, it is nothing but it will apply on this one. alpha x implies beta. So it is nothing but, see here, the meaning of this one is nothing but alpha 1 implies beta, fine, and my dear friend, alpha 2 implies beta, alpha 2 implies beta. So this is the meaning of C, my dear friend. What I'm telling, see, alpha 1 or alpha 2 implies beta, implies alpha 1 implies beta, due to for all x it will become and alpha 2 implies beta. Now see clearly, so whether it is tautology or not, whether it is valid or not. So see clearly, whether it is valid or not, they are asking about. Valid hai ki nahi hai. So left hand side always true, you know. Left hand side true. If somehow you prove right hand side false, it means it is not valid. और अगर आप right hand side को false ले लें, fine, false लेना और इसको true proof कर दें, तो ये क्या होगा? Valid नहीं होगा. तो if you see clearly, this should be true. This should be true, my dear friend. This should be true. Fine. ये इसको true बनाना है आपको. So true बनाना है, my dear friend. So either you can take directly, sir, beta cannot be false. Fine. If beta is not false, definitely left hand side will be true. Are you getting my point? Beta will not false. So if beta is not false, fine, beta is not false. So this is true and this is true. So overall true implies true is tautology. But somehow you want to this one make as true and this one make as false. So let me take beta as true. Let me take beta as true, my dear friend. If I take beta as true, my dear friend, beta as true, fine. So true. Let me take beta as true. So let me take, see here, I want to make this one false. I want to make this one false. Can you make it false, my dear friend? Can you please let me know? See, beta is true. Beta is true. तो देखो, अब मुझे इसको true बनाना है ना, इसको मुझे true बनाना, तो alpha 1 को अगर आपने true बना लिया, this should be true ना, तो alpha 1 अगर true बन गया, so true implies true क्या होगा? True हो जाएगा, और alpha true false हो गया, तब भी क्या हो जाएगा? False implies true क्या हो जाएगा? True हो जाएगा, and this is nothing but and operation, true and true is true only. Fine. Are you getting my point? So anyhow, you are not able to, if you take left hand side as true, you are not able to make right hand side as false. So my dear friend, that's why C will be the correct answer. C will be the correct answer if anyone have any doubt. Fine. Either you can do like this also. See here. आप इसको ऐसे लिखो, देखो, alpha 1 plus alpha 2 implies beta. This is left hand side. If you solve this, it is nothing but, see here, alpha 1 bar into what? Alpha 2 bar plus beta. This is what your left hand side, alpha 1 bar into alpha 2 bar plus beta. If you take right hand side, if you solve this, it is nothing but, see here, alpha 1 bar plus beta into what we have, into what? Alpha 2 bar plus beta. Fine. If you solve this one, it is nothing but alpha 1 bar, alpha 2 bar. Fine. And what we have? We have what? Alpha 1 bar beta. Fine. I'm writing 1 here, no problem. And what we have? And plus we have what? Beta alpha 2 bar, and what we have? Plus beta. Are you getting my point? Now you can simplify this. See, if you take beta common, so it is nothing but alpha 2 bar. Fine, because beta common, so 1 plus alpha 2 bar is nothing but alpha 2 bar. Fine, beta. Let me take beta common. So it is nothing but 1 plus alpha 2 bar. So 1 plus alpha 2 bar is nothing but 1. So this is nothing but 1. Once again, if you take beta common, so it is nothing but beta. So it is nothing but alpha 1 bar, alpha 2 bar plus beta. So see here, alpha 1 bar plus alpha 2 bar plus beta. So C. Only in the case of C. It is coming same. So see, this kind of question, people may got confused also. Fine. Once again, I'm telling, करना कुछ नहीं है. What you need to do, x की value up, you can take x value 1 and 2. ठीक है. Maximum 1, 2, fine. Just take x is what? 1, 2. Fine, 1, 2. You should know the meaning of there exists. There exists means matlab or, means alpha 1 or alpha 2 implies beta. For all, meaning for all is up. See, for all x, it will go through till here to till here. It means alpha 1 implies beta and alpha 2 implies beta. Now, if you prove, see, left hand side, you know, left hand side is true. If you prove somehow right hand side is false, it means true implies false is false. So see, when it will be true, my dear friend, when it will be true, let me take alpha 1 is true. If this is true and beta is true, you cannot make right hand side as false. See here, if alpha 1 is true and alpha 2 is false, you cannot take right hand side as false. You cannot do. Anyhow, you cannot do, my dear friend. Fine. I think, hope this one is clear. If you want, I can explain A option also, and rest of option you can try by your own. Fine. This is good question. Okay. So I'm removing now because I don't have a space. Okay. Or just I explain little bit upper here. Fine. See, What about this one? They are telling beta implies there exists x alpha x. Fine. So it is nothing but, see here, that is not, they are telling actually beta implies alpha 1 or alpha 2 or alpha 2. This is nothing but left hand side. Beta implies alpha 1 or alpha 2. This implies the right hand side, they are telling beta implies alpha 1 and beta implies alpha 2. So if you solve this with the help of digital also, it will not be equivalent. Fine. Or if you want to write in the form of proposition, means you can write beta implies alpha 1 or alpha 2. Fine. This implies beta implies alpha 1 alpha 2. Fine. So you can take, see here. See, this one definitely, it will not be a tautology. If you see here, this one definitely will not be a tautology. It will not be a tautology. Are you getting my point? This will definitely will not be a tautology. Is that clear? Fine. So, yeah, because this is and now, this is and, my dear friend. This is and. This is and. If you take, my dear friend, see this. If you take this one is true, let's suppose this one is true, and yeah. And this one is false, and this one is true, my dear friend. So see, true implies true is true only. Fine. This left hand side is true because true implies false or true. What is false or true? True implies true is true only. Now beta is true. Alpha 1 is what? False. So see here, 2 implies false is false, and something is false. So right hand side kya ho gaya? False ho gaya. It means it is not a tautology. Very simple. So I think you are getting my point. So C is the right answer for this one. Fine. It's up to you which method you want. Okay. See this question. They are telling a binary relation R on n cross n is defined as follows. See here, ordered pair is related. AB related to CD. बोल रहा है AB related to CD if and only if A less than C or B less than D. Means see here, ordered pair they have given AB, CD, fine, and they have given, my dear friend, see A less than C, or they have given B less than D, Fine, less than equal to लिखा हुआ है, less than equal to they have written. See here, so they are asking P proposition is R is reflexive. Yes, definitely it is reflexive. What is reflexive? For every A belongs to A should be related to A. That is the meaning of reflexive. For every A belongs to A should be related to A. Now for ordered pair, for every ordered pair A comma A, it should be related to what? A comma A. Are you getting my point or not? If you talk about any number, fine. Let's suppose n cross a natural number they are telling. So 1 comma 1 related to 1 comma 1. Why? Because see here 1 is less than equal to 1 and this one is also less than equal to 1. Even though they are writing OR. So if this one also less than equal to 1, it is satisfied. So every ordered pair will be related to itself. Yes. So it is reflexive. So this one is nothing but this one is reflexive. Fine. Now if you talk about transitive. My dear friend. So for transitive it is better. You can prove not transitive. Fine. That is very easy. Fine. Transitive proof karna like it is quite difficult, but if you better like prove not transitive. So you can write any relation. Let me write here. Let me we have 2, 3. And we have, let's suppose 3, 1. Here 2 less than 3. Yeah. 2 less than equal to 3. So it will be related. 2 comma 3 and 3 comma 1 be related. Now if I will take see here 3 comma 1. Let me write here 3 comma 1. And 1 comma 1. Fine, 3 comma 1, 1 comma 1. So 3 less than equal to 1? No. But 1 is less than equal to 1. So it's also related. It also related, my dear friend. So AB related to CD and CD related to what? Let's suppose EF. So AB should be related to what? EF. Are you getting my point? AB should be related to what? EF. So if you see clearly, 2 is not less than equal to 1 and 3 is also not less than equal to 1. So this ordered pair will not be there. So it is not transitive. So you can write many of example like that only. So see here how it will come. It comes with the help of practice. Fine. So not transitive, it is quite easy to write. Fine. If you see not transitive, proof karna aasan hota hai. So you should be prepared with any ordered pair. Oh, see 2, 3 and 3, 1 is there. It should be relation, but 3, 1 and 1, 1 is there. So 2, 3 and 1, 1 should be there, but it will not be there. Why? Because 2 is not less than 1 and 3 is not less than 1. So that's why it is not transitive. So I think P is true and Q is false. So Q is false means B is the right answer for this one. Fine. B is the right answer for this one. Fine. B is the right one for this one. Are you getting my point? Okay. B is the right one for this one. Okay. Now see clearly this question. This question, my dear friend. Consider the field C of complex number with addition and multiplication. Which of the following form S is a subfield of C with addition and multiplication? Fine. So see, like in 2008, they have asked one question based on field and subfield also. But in nowadays, they are not asking about field and subfield and ring question. Fine. So, but yeah, this question has came in 2008. So that's why I'm explaining. So see clearly. So like subfield also, like it should be closed. Fine. It should be closed. And it should be what multiplicative, it should be what associative and commutative. And it should be what multiplicative inverse and additive inverse. Fine. And like on non-zero value. On non-zero value here, fine. On non-zero value should be exist, fine. Multiplicative inverse and additive inverse, fine. And it should be all distributive. Plus, like star is distributive over plus and plus is distributive over star. So that is the property of what? Subfield. So now if you see some property and you are able to give the answer of this question, see, now if you take S1, set of real number. Set of real number. So if you take any two real number and if you add two real number, see, it will be real number only. Fine. It means it is closed. Fine. So addition is closed. If you take two real number and if you multiply it, it is also what? Real number only. So it is closed, my dear friend. Let me take closed property first, because if anyone violate closed property, it will not a property of subfield. So first you take closed property satisfy in all or not. Fine. First, fine, you can see clearly. So the set of real number, my dear friend, the set of real number, it is closed. Definitely it is closed. No problem. No problem. Multiplicate, chahe multiplication or chahe addition ho, fine. If you multiply two real number, real number. If you add two real number, fine. Now, if you see clearly this one, A plus IB, where A and B are rational number. They are telling A and B are rational number. So if you add two rational number, fine, it will be a rational number. If you multiply two rational number, it will be rational number. So it is also closed. But see clearly in this one, they are telling A plus IB, A plus iota B, A square plus B square less than 1. A square plus B square less than 1, my dear friend. Fine. So if you see this one, A plus IB and A square such that A square plus B square less than equal to 1. If you think like this, see, let me take some 2 points here, like 0.3 and 0.4. Fine. And let me take here 0.7 and 0.6. Let me take. See clearly here. And if you take 0.3 and 0.4, and if you do square of this one, fine. And if you do square of this one, 0.3 square plus 0.4 square, it will be less than equal to 1. So this will be in the relation. Fine, no issue. What about gate DA? DA, I think already has been started on YouTube. Satya sir has taken classes. You can watch the class. Fine. Fine. And for more clarification, you can just go in description, just join the Telegram link, and you can ask question. Fine. Okay. So see clearly here. So 0.3 and 0.4, my dear friend. If you square plus add, it will be less than equal to 1. So that 0.7 plus 0.6 is also what? If you square, it will be less than 1. And if we add this, it will become, it is nothing but, see, it is nothing but, my dear friend, 1 plus I. Fine. 1 plus I. Is that clear? 1 plus I. So see clearly here, but see here, now A square plus B square is not less than equal to 1. Why? Because see, what is the coefficient of this 1? What is the coefficient of this 1? So 1 plus 1 square is what? 2. 2 is not less than equal to 1. So this is not closed. So this is not closed, my dear friend. This is not closed at all. This is not closed. This is not closed. Okay. This one will be not closed. And what about this one? See, IE such that A is real. IE such that A is real, my dear friend. So this one also, see, if you talk about for this one, I think identity will not exist. Why? Because see, with the multiplication, like with multiplication, like 1 is the identity, but anyhow you cannot get 1 because see, iota is there, na? Iota there. It might be closed because they are asking about A is real. So definitely A will be always real if you take any one, like 3i, 4i, but 3 is real, now 4 is real, 5 is real, so it will be closed. But if you see clearly, you will not get 1. Identity 1 will not be exist due to this one because they have written I here. So so here identity is not exist. Identity is not exist. Now if you talk about this one, see here. Now subfield, like all the properties should be there. Like I told you, like first is what? Closure. Fine. Okay, fine. Definitely I will explain. See clearly. Set of real numbers. So it is closed or not. If you add two real number or multiply two real number, it is what? Closed. Fine. Next one is nothing but what it is, what associative is not, associative or not. So addition is associative in nature, you know, multiplication is associative in nature, fine, no problem. Now if you talk about additive identity, 0 is the identity for this one, and multiplicative identity, 1 is the identity for this one, fine. And if you talk about inverse also, fine, if you take any number, additive के according inverse क्या होगा, minus है, fine. Inverse will be minus है, fine. Or multiplicative के according inverse क्या हो जाएगा, 1 by a हो जाएगा. So all thing is there, and it is what distributive also. Plus is distributive over star, and star is distributive over plus. So no problem. So yeah, S1 no problem. We don't have any problem here. Like that, we don't have problem in S2 also. S2 also what? It is what, close, associative, and commutative. Identity is there, inverse is there. Fine, everything is there. But here it is not closed, and here we don't have any identity. For multiplication, we don't have any identity. Fine. So that's why S1 and S2 will be correct. So D will be the right answer for this one. D will be the right answer for this one. Fine. For this one, D is the right answer. We have more questions, so I'm moving now quickly. So D is the right answer. If you have doubt, you can ask me. Okay. Now, if you see this question basically you can relate with the graph theory. Fine. Now you can read this question. What their question telling? I am telling in terms of graph theory. They are telling there are 23 vertices in the graph. 23 vertices in the graph. Fine. 23 vertices in the graph. And my dear friend, there are what in a subgraph. This is graph you can take, and in a subgraph there is 9 vertex. Subgraph there is a 9 vertex. Subgraph 9 vertices is there. Fine. And they are also telling in subgraph, fine, where what number of vertex is 9, each have degrees what 3. Each have degrees what 3. So see here in subgraph, all 9 vertices have degree 3. Means they are written clearly. The 9 compounds, each of which react with exactly 3 compounds of U. It means they are connected with, see here, 3 edges. Fine. Means on every vertex 3 edges will be incident. Fine. So that the degree will be 3. Fine. Now they are asking something. Each component in U by S means U minus S you can write, with an odd order of compound. At least one component in U by S reacts with an odd number of compounds, fine. And each compound in U by S reacts with even number of compounds, fine. So if you know the first theorem of graph theory, always true they are asking. If you know the first theorem of graph theory, Handshaking lemma, it is nothing but sum of degree of vertices is nothing but 2 into number of edges. Everyone know. Fine. Sum of degree of vertices is nothing but 2 into number of edges. Are you getting my point? 2 into number of edges. So 2E is always even. 2E is always even, my dear friend. 2E is always even. Fine. Everyone know. So see here. Now we know already like the degree of subgraph. See here. So it is nothing but the degree of subgraph is nothing but 9 into 3. 9 into it is nothing but 27. 27 is an odd number. 27 is an odd number. Plus you should know the degree of what? U by S. U by S means U minus S. Remaining vertices. What about the remaining vertices? See, this is odd. This is odd, my dear friend. And total sum is what? Even. So this should be what? This should be what? My dear friend, this should be what? Odd. Odd, my dear friend. So at least it doesn't mean like each compound in U by S reacts with an odd number of compounds. No, my dear friend. At least one compound in U by S means at least one vertex should be there in U by S with odd number of compounds, with odd number of degree. Fine. So at least will be true. It's not for everyone. You cannot say like everyone will be have odd degree. No, it is not like this. So see, at least one compound in U by S react with an odd degree. So this should be odd, my dear friend, and at least one should be there. So the answer will be what? Second one. So answer will be what? Second one. So B for Bombay is the correct answer for this one. B for Bombay is the correct answer for this one. Fine. So you can relate with the graph theory and just apply Handshaking lemma. Fine. And you know like odd plus odd will be even. Fine. See, it should not be even. ये तो third option तो होगा ही नहीं ना. Third option तो होगा ही नहीं. But see clearly, my dear friend, here you cannot guarantee like each component in U by S, in U minus S means remaining vertices have each component have odd degree. No. Are you getting my point? Fine. But at least one component should be odd. Yes, definitely at least one component should be odd. Yeah. So that's why this one is the right answer. 16 is the right answer. Okay. Now see this question. This question is also a good question. Fine. So they are telling a function f which is mapping to positive natural number to natural number defined on the set of positive integer. Satisfy the following property. They are telling fn equal to fn by 2 if n is even. Fine. And fn equal to fn plus 5 if n is odd. Let r equal to I such that there exists j there exists J, f j equal to I be the set of distinct value that f take the maximum possible size of R. They are asking what maximum possible size of R. What is the maximum possible size of R? See, for this one, so you need to take some value, like, let me take some, for this one, for solve such type of question, you can take, see, let me take f1 equal to 1. Let me take f1 equal to 1, f1 equal to 1. Let me assume f1 equal to 1, fine. So what about f2? f2 is an even number, so f2 is nothing but, see, it will be fn by 2, it is nothing but f of 1, and f of 1 is also 1, fine, so 1, okay. Now, if we take, say here, f3, so f3 will be go where? Fn plus 5, because 3 is an odd number. So it is nothing but f of 3 if we'll take. So it is nothing but f of 8. 3 plus 5 is nothing but f of 8. F of 8 means even number means f of 4. F of 4 means f of 2. And it is nothing but what? 1. F of 2 is 1. Fine. Now, try for f4. Try for f4, my dear friend. F4. So if you try for f4, f4 is, you know, f4 value is what? F2, it is 1 only. Try for f5. If you try for f5, it is clearly f5. Fine. F5. So F5 is an odd number. It is nothing but f of 10. F of 10, my dear friend. So F of 10. So you cannot assign any value of here. So you can assign some other value. Now they're talking about maximum possible size of R. So you can take some other value. Fine. Because they are asking about maximum, not minimum, my dear friend. Minimum, so you can take 1 only. But maximum, so you can get other value. Let me take 2. Let me take 2. Fine. So F10 is nothing but 2. Now, if you talk about, see, F10 is nothing but 2, my dear friend. Okay. Now, if you talk about, see, any other one, let me take F15. So, or let me take F15. Okay, F15. It is odd number. So, it is nothing but F20. F20. So, F20 is nothing but F10. And F10 is nothing but 2. Fine? F2. So, if you take any value, maximum 2 distinct value you will get. Maximum 2 value. So, the answer for this question is nothing but 2. The answer for this question is nothing but 2. The answer for this question is nothing but 2, my dear friend. Fine? इसका आंसर क्या होगा? 2 होगा. Is that clear? Okay. Now, see clearly this one. The solution of the recurrence equation. Fine. So this type of question you can have with you can try with the help of hit and trial also. Fine. Hit and trial. See here. Let me take here. Put k equal to 0. If you put k equal to 0. It is nothing but 2 to the power 0. It is nothing but t1. So this value will be 1. So if you put 0, you will get 1. You will get 1. So if you put 0 here, so 2 to the power 0 is nothing but 1. Fine. And if you put 0 here, it is nothing but 3 minus 1 by 2. It is nothing but 2 by 2. It is nothing but 1. Fine. If you put 0. Fine. Now if you put 0 here, it is nothing but, see here, 3 to the power infinitive. And this is also 2 to the power infinitive. Fine. Now try for C. Now see, it is, now you can remove C and D option here. You can remove C and D option. Now we have left with A and B, my dear friend, A and B, because both are same. Now you can go for 1. So if you put 1 here, so if you put 1 here, what you will get? So it is nothing but 3t 1 minus 1. So 0. 2 to the power 0. It is nothing but 1. 3t1 plus 1. So what you will get, my dear friend? 3t1. T1 की value क्या दी है 1. So it is nothing but 3 into 1 plus 1. It is nothing but 4. You will get 4 here. You will get 4 here. Fine. Now, if you see clearly, now if you put here k equal to 1. So 2 to the power 1 equal to what? 2. Here you get 2. Fine. I think then you can go with the B option. You have left with only B. So if you want, you can put also. Fine. Let me put 1 here. Let me put 1 here. So it is nothing but 3 to the power 2 minus 1. Fine. Divide by 2. It is nothing but 9 minus 1 divided by 2. It is nothing but 8. So 8 is, yes. So, oh no. 8 divided by 2. It is nothing but 4. Yeah. 8 divided by 2. No. 8 divided by 2. 9 minus 1, 8. 8 divided by 2, 4. So, yeah, 4 it is coming. Yes. So, B is the right answer for this one. B for Bombay is the right answer for this one. Okay. B for Bombay. Now, if we see correctly this one, let xn denotes the number of binary string of length n that contain no conjugative 0. No conjugative 0. Fine. Okay. So, which of the following recurrence does xn satisfy? So, they are telling which of the following recurrence does xn satisfy? And they're asking about no conjugative 0. So, see, if you have, see, for x0, my dear friend, see here, for x0, it is 0 and 1. Is there any, for 1 bit, for 0 bit, see here, either you can represent or 0 or 1. Is there any no conjugative 0. See here, length of n that contain no conjugative 0. No conjugative 0, my dear friend. So is there any conjugative 0 here? Is there any conjugative 0? No. No. So I think x0 is what? 2. x0 is what? 2. Are you getting my point? No conjugative 0. So see here in 0, we don't have any conjugative 0. In 1 also, we don't have any conjugative 0. Now we have what? 0 and 1. 0 and 1. And 1 for also we have what? 0 and 1. So for x1, my dear friend, see for x1, for this one, see here we have conjugative 0. So see this one 0 1 is not conjugative 0, 1 0 is not conjugative 0, and 1 1 1 is not conjugative 0. So what we have for x1 is it is nothing but 3. For x1 is nothing but 3. Now if we talk about x2, my dear friend, so see here, so this one will not be considered. Fine. Now if you take 0 1, fine, you and see here, so 0 and 1, fine, 0 and 1. So if you see this one, so see, so 1 0, yeah, 1 1 1 2, yes, 2, then 0 0 will not be considered. Fine, 1, so 3 4 and 5. So this is nothing but x2 will be what? 5. X2 will be what? 5. So that you can get sorry, not x2, yeah, x2 will be 5. x3 will be what? You can get 8. x3 will be what? You can get 8. I think it is clear. Now you put here in the option. It is very easy. You can put in the option and you will get. Okay. Try this. Try this. Fine. Whether you are getting this one or not. Fine. Whether you are getting this or not. Fine. You can try here. So if you put, see here. Let me put here 2. So 2. If you put x2, it is nothing but x1 plus x0. What is x1? x1 is 3. What is x0? x0 is 2. So x2 is nothing but 5. You are getting 5 here. See clearly in third option. See clearly you are getting 5. So if you try here also xn. If you try put 2 here also, fine, x2. So it is nothing but, see here, x2. It is nothing but 2x2 minus 1 is nothing but x1. 2 into x1. What is x1 value? 4. So it is 4. 2 into 2. That is nothing but 4. So x2 is not 4. So it is incorrect. So A is gone. Now you can try for this one also if you want. xn by 2. What is n? N is nothing but 2. I am taking 2 here. So 2 by 2 is nothing but 1. So x1 is nothing but 2. So 2 plus 1, 3. So it will not be the answer. It will not be answer. If we put here n value is what? 2. N value is what? 2, my dear friend. So it is nothing but x1. What is x1? x1 is 3. Fine. And this is 2. So here it is coming 5. So maybe C also correct, maybe D also correct. So whenever two option is matching, here C also matching and D also matching. So go for next one. Go for next one, x4. Go for 3. Go for 3. Abhi 3 bhi to hai. So you can put 3 here. Now in both options you can put 3 here. So what is the x3 value? If you put x3 here, my dear friend, what will be here? 3 by 2. What is 3 by 2? Floor value it is taking. 3 by 2 is 1. So it is nothing but x1. x1 plus 3. What is x1? x1 is 3. So 3 plus 3 is nothing but 6. But it is coming 8. So it is wrong. So C you can remove here. C is the wrong option. Fine. Now if you want you can try here. आप इसमें try कर सकते हैं. Last वाले option में xn equal to xn minus 1 plus xn minus 2. Fine. So what we have here xn minus 1. So I am putting 3's. It is nothing but x2 plus 3 to 1 x1. So what is x2? x2 is nothing but 5 and x1 is nothing but 3. So 5 plus 3 is nothing but 8. Fine. 5 plus 3 is nothing but 8. Is that clear? 5 plus 3 is nothing but 8. Okay, if you want, you can write like this. You can take x1, x2, x3, x4. Fine. You cannot take, if you don't want, yeah, no problem. I think it is okay. Fine. 5 plus 3 is 8. Fine. You can go for x5 also if you want. I think 13 will come. If you are doubt here, देखो मैंने कैसे लिखा है 0 1 लिया ना, तो 0 1 फिर 0 से क्या मिलेगा 0 1 मिलेगा, फिर 0 1 मिलेगा. तो यहाँ पे देखो यहाँ पे नो कॉन्जुगेटिव 0 कितने आ जाएंगे 2 आ जाएंगे ना. दैट्स व्हाई द वैल्यू इज 2. ठीक है. फिर देखो 0 0 वाला तो काउंट होगा नहीं बिकॉज आई डोंट वांट no conjugative 0 will be there. So 0 1 will be there. That's why I will count 1 here. 1 0 will be there and 1 1 will be there. 1 1. That's why this x1 is 3. This is x1. This is x2. The next 3, the next 4. Like this, you can move on. Okay. Okay. I'm moving forward. So for this one, I think D. You can try. X5 is what 13. Okay. You can try. And for this one, it is similar one. Fine. I think we have done already, and they have given in terms of what A. So you can try here. See here. So now they are telling no, not contain 2 consecutive 1, means 0, 1. I think you know A0 is nothing but 2. Now we have 0, 1, 0, 1. Fine. Now no 2 consecutive 1 they are telling. So see clearly, so it will count, fine, it will count. So this will not count. So what we have, A1 will be what? 3. Now if you see clearly, so no 2 consecutive 1. So see clearly, here we have what? 0 and 1. Fine. Here we have what? So this cannot be 1 and 0. So this cannot be option, obviously. Fine. Here we have 0 and 1. And here, obviously, you cannot take this one. Fine. No 2 consecutive 1. Fine. So I think you can count, and A2 will be what? 5 here. 5 here. Like A3 will be 8 here. Fine. So that's why you can put in the option and you'll get, I think the option is what? B. Same as like what we have done in previous example. Okay. Now, the exponent of 11 in the prime factorization, 300 factorial. Fine. So it is nothing but 300 factorial is nothing but, you know, like it will go to 1. So if it will go to 1, my dear friend, 11 will be there, and many of 11 factor will be there, like 22 will be there, 33 will be there. Are you getting my point? So that like how many like prime factorization will be there? So you can just divide it into 300 divided by about 11. 300 divided by 11. Are you getting my point? Fine. Because in 300 factorial, we have many numbers. See, we have 11. We have maybe 22. 11 into 2. We have 11 into 33. Fine. Like many factors of there. So how many factors will we have? Like that we have 27 factors. But maybe also we have 121, 240, 242 also will be there in this one, in 300 factorial. So more 2 factorization. Fine. So 27 plus 2 and 29 will be the answer. But what you do in the exam, just क्या करना है आपको? See here, 300 divided by 11 plus, see here, the answer. Now 27 divided by 11. Now see here, until you can get 0, fine. 2 divided by 11, fine. That's it. That's it, my dear friend. See here. So see here 27, here you will get 2, here you will get 0. Fine. So 27 plus 2 is nothing but 19 will be the answer. Fine. So you can do, I think this is already covered in your aptitude part. So answer will be 29. So C is 29 will be the right answer. Very simple, like 300 divided by 11. Fine. And we have factors like 121 and 242. So 2 more factors. So that's why we are adding 2. So what we need to do, just divide by 11 until it will become 0. When it will become 0, stop. It will become 0, my dear friend, stop. Fine. So 300 by 11 plus 27 by 11 plus 2 by 11. So here you can stop here. You can get 0 here. You can stop here. Fine. So it's 27 plus 2. Answer will be 29. Okay. This is question of generating function, my dear friend. So whenever they will ask, see here. So it will go to the infinite. So क्या करना है आपको इसको लोअर लिमिट पे लेके आना है. फाइन. So lower limit में लाने के लिए क्या करना पड़ेगा? You need to take common x cube here. Fine, x cube. So if you take common x cube, so it is nothing but 1 plus x square plus x cube and so on and dot का whole cube. Fine. Ka whole cube, my dear. I think you know. Fine. Lower base पे लेके आना. This is nothing but, you know, infinite GP series. So it is nothing but, see here, x to the power 9, my dear friend, and it is nothing but, see here, x to the power 9 I am writing 1 upon 1 minus x. Fine. 1 upon 1 minus x ka whole cube. Fine. So this is nothing but, you know, I think n minus 1 plus RCR. If you know the generating function, you can solve this. So x to the power 9. This is nothing but r to the power 0 to infinitive. N minus 1 plus RCR. Fine. X to the power r. X to the power r. Now they want x to the power 12 coefficient here. Fine. We have already 9 here. Fine. So we have already 9 here, my dear friend. So see clearly here. So what? See. So here what we want actually, we want here 3. We want here 3 minus 3 here. No? We want 3, my dear friend, here. 3 here. So what will be the coefficient of this one? Fine. So it is nothing but, see here. If you put here, what we'll get? So it is nothing but, I think you will get 10. 10 as a, you will get 5C2. You can just solve this. You will get 5C2. 5C2 and 5C2 or 5C3. It is nothing but 10. It is nothing but 10, my dear friend. Fine. It is nothing but 10. Okay. It is nothing but 10. So 10 you will get, fine. 10 you will get. You just solve this and you will get 10 here. 5C2 answer will be 10. Okay. I'm moving now. So this one also based on what? N minus 1 plus RCR. Same formula. Fine. And if you multiply this, because they are asking about B blue balls and R red balls. So I think you N minus 1 plus BCB into what we have? N minus 1 plus RCR. If you multiply, you will get A as an option. If you multiply, you will get A as an option. So for this one, for 24, A is the correct option. Okay. Now see this question. Let P equal to sigma 1 less than I less than 2K. I is odd. And let Q is what? Sigma I 1 less than I less than 2K. I is even. Where K is a positive integer. So this question also you can try with the help of hit and trial. You can take K as what? 3. So see here 2K hai na? So it will go to 6. So here we will get odd number, means you get 1, 3, 5. Here you will get what? 2, 4, 6. If you put K3, K3 my dear friend, K3. So where K is a positive integer. Now their summation hai na? So you can add 1, 5, 3, 5, 3, 8, 1, 9. So it is nothing but 9. So P is nothing but 9 here. And Q is nothing but 6, 4, 10. 6, 4, 10 and 10 to 12. 6, 4, 10 and 10 to 12. Yes, P, this is 10. This is 12, my dear friend. Fine. So I think if you put here, in which value to satisfy? P is 9, Q is 12. So 12 and K is 3. Yeah, in the first one, it is satisfy. Only in the first one. If you see clearly, only in the first one, it will satisfy. So the answer is what? 1. The answer is what? 1. Fine. Is that clear? Okay. Now, this question you need to try. Fine. This is also like, it is quite lengthy. You need to solve only. Just put A n value, n minus 2 value. So you'll get this one. It is easy one. Answer will be, I think, K value will become, I think, 108 into 10 to the power 4. You can try. Fine. If you have doubt, you can ask. I will, in Telegram group, if you have any doubt regarding this question, you can ask me. It is easy question. Just need to expand. Fine. Okay. The minimum number of color required to color the vertices of a cycle will add nodes such a way that no two adjacent nodes have the same color. So, you know, in cycle, fine, if it is odd cycle, you know, 3 color. If it is even cycle, you know, 2 color. Fine. If it is even cycle, it is 2 color, you know, because see, this is not adjacent, na? So you can color with 1, you can color with 2. So minimum 2 color, but all here adjacent. So 3 color are required. So obviously 2, 3, 4 will not be the option. So if you go with this one, my dear friend, it will be the answer. Fine. This one will be the answer for this one. If you put here, fine, this option will be satisfied. So D for Delhi is the right answer for this one. Because here, already I told in the class, for odd it is 3 and for even it is 2. For odd it is 3 and for even it is 2. Fine. So it is nothing but, yeah, n minus 2 and it should be what? Floor value. N by 2 plus 2. N by 2 plus 2. Okay. If you want, you can take any value, it will satisfy here. Fine. If you take, see here, n value is 3. So it is nothing but 3 minus 2 into 3 by 2 is nothing but 1. 1 plus 2. So it is nothing but 5 minus 2. It is nothing but 3. Yeah, it will satisfy. Now if you put odd, like even if you put, so 4 minus, see here, 4 minus what? 2 into what? 2 plus 2. So it is nothing but 6 minus 2. It is nothing but 4. Yeah. So that's why D is the right option. Right? D for Delhi is the right option. Okay. Now, maximum number of edges in an n node undirected graph without self loop. Without self loop, it is nothing but, it is number of edges in the complete graph, NC2. It is nothing but n into n minus 1 upon 2. So B for Bombay is the right answer for this one. For this one, if you see clearly, what is the chromatic number of this graph? So see here. Here we have a cycle. Here we have a cycle. Here we have a cycle. If cycle is there, minimum 3 color are required. Fine. If cycle is there, minimum 3 color are required. Fine. At least 3 color are required. Now, if you see clearly, if you want to color also, let me color with 1. 1. Color with number 1. Can I color with 1? No. 1. Yes. Can I color with 1? Yes. Can I color with 1? 1. No. Can I color with 1? Yes. Can I color with 1? No. Can I color with 1? No. Okay. Fine. Now see clearly. Okay. Can I color with 2? No problem. Can I color with 2? This one 2. No. Can I color with 2? 2. This one no problem. Fine. Okay. Can I color with 2? This one no problem. Fine. Now this one is remaining. Can I color with 1 or 2? No. So minimum one more color. So 3 colors are required. So for this one we have 3 colors are required. Okay. So that's why 3 is the right answer. What is the size of smallest maximal independent set of a chain of 9 node? So they are telling chain of 9 node. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 node. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 nodes. So they are talking about the smallest MIS. The smallest MIS, fine. So maximal independent set, like no adjacent vertices, no adjacent vertex will be there. Fine. Maximal independent set, independent set means no adjacent vertex will be there. And when it will maximal, my dear friend, if you add any other vertex, it will not be a maximal independent set. Fine. Let me tell you also. Okay, can I write 1, 3, 5? See here, 1, 3, 5, 7, and 9. Yes, this is MIS. Yes, this is MIS. But they are not interested about MIS. They are interested about smallest MIS here. Fine, smallest. Okay. So can you write here? See here, 2, 5, and 8. Fine. This is MIS or not? See here, 2. Can you add anything? See here. Can you add 1, 3? No. Can I add 4 or 6? No. Can I add 7 or 9? No. See, this is what, see here, this is maximal independent set because you cannot any other vertices. You cannot add any other vertices. Fine. If you add any other vertices, it will not be a maximal independent set. So 2, 5 it is also maximal independent set. So among those, see, this is minimum. This is smallest one. Fine. इसके अलावा भी और हो सकते हैं, but this is the smallest one. Fine. 2, 5, 8. So that's why the answer will be 3. So for this one, answer will be what? 3. 3 will be the right answer. Okay. Now, in this question, they are telling, let G be a simple connected undirected graph. Some vertices of G are of odd degree. Add a node V to G and make it adjacent to each odd degree vertices of G. The resultant graph is sure to be. They are telling G is a simple connected graph. Fine. Undirected graph. Some vertices of G are of odd degree. Add a node of V to G and make it adjacent to each odd degree vertices of G. What does mean actually? See, they are telling some vertices of odd degree, means some are even, fine. And they are also telling add one more vertex and add to that vertex which having odd degree. Add and make it adjacent of it. Means what? In a connected graph, every vertex has what? Even degree. It means in a connected graph, if every vertex have even degree, it is nothing but a Euler graph. Fine, you can take this one. You can take this one. See here, degree is 2, 2. Here degree is 3, 3. Now that they are telling add one more vertex, take one more vertex and make adjacent to it. Make adjacent to it. So now the degree will become 4. The degree will become 4, and this one become degree is what? 2. Are you getting my point or not? So all connected graph, degree is even. So Euler graph. It is nothing but Euler graph. So D is the right answer for this one. Easy question they have asked. Okay. Now for this one, see here. They are telling which of the following statement is true for every planar graph on n vertices. The graph is connected, need not be. It can be disconnected also. Planar graph can be disconnected also. Fine. The graph is Eulerian. No. Every planar graph is not Eulerian. See, this is a planar graph. If you see clearly. Fine. This is a planar graph. Fine. This is a planar graph. Yes. You can draw like this. You can draw like this. This is a planar graph. Fine. But is it Euler, my dear friend? Is it Euler? No. Fine. So the graph is Eulerian. No. So this is right actually. The graph has a vertex cover of size at most n3 by 4. Fine. We have seen already. And this is false. The graph has independent set of size at least 3 by n by 3. No. This is false. We have seen in the theorem. Fine. So this is C is the correct answer for this one. Fine. C is the correct option. You can just C is the correct option for this one. The minimum number of color that is sufficient to vertex color in a planar graph. 4 color theorem. Answer is what? 4. This is based on 4 color theorem. Answer is what? 4. Okay. Yeah. So see, my dear friend, on 13th September, 7:13 p.m. you can join Asu Jangra sir classes for ideal strategy to excel in GATE 2024. Fine. And also, like, see, on 10th September, we have a scholarship test program. You can get maximum 90% discount. And you can enroll in Vision batch, whether already we have started live classes, fine, and recorded lectures are there, study materials are there. So this is important for you. Yeah, and you can join my Telegram link for daily notification. Please like and subscribe the channel. Yeah, thank you so much. And we'll meet you tomorrow. Fine. Thank you so much. If you have any doubt, you can ask me if you have any doubt. Thank you so much.